Now down here, let's take a look at this one quickly. Now because the notation here may not be crystal clear to everyone, I thought we would go ahead and just perform the shuffle at least. Okay, so this is called an RC shuffle. R is for row, C is for column. I use that name because it reminds me that the stay stack principle may very likely apply to that shuffle. Okay, so let me go ahead and interpret what this is. So what you're doing here that's different is you're dealing into 4 piles. Okay, that's different. We were dealing into 2 before. So you're dealing into 4 piles, like so. So we call this pile 1, 2, 3, 4. Okay, so what's being noted here? Well, in mathematics, you do the innermost parentheses first. Well, that would be these 2. So that indicates we should put pile 1 on top of pile 2. Okay, so we've done that. Now we take this and stack it on top of pile 3. And then we take all of that and stack it on top of pile 4. So really all of that can be summarized as just stacking the piles from left to right. Okay, that's a way to mathematically notate stacking the piles from left to right. Well, the claim is that we're going to get a permutation and cycle notation that looks like that. Okay, so let me just show you what we get first, and then we can just point out the details here that I've already written up. Okay, so we got 5, 1, 6, 2, 7, 3, 8, 4. 5, 1, 6, 2, 7, 3, 8, 4. Okay, so this is in the Cauchy 2-line notation. That can be pressed down to single line notation, in other words, cycle notation. So 1 goes to 5, 5 goes to 7, 7 goes to 8, 8 goes to 4, 4 goes to 2, and then 2 goes to 1, and then that means we've cycled back around. Okay, so you can write this more succinctly as 1, 5, 7, 8, 4, 2. Okay, so this is a 6 cycle, and so it would take performing this shuffle 6 times for all of these values to be reset to where they originally started. Okay, and then we haven't, this is only 6 of the 8 values, so there's still 2 that we need to account for, and that would be 3. 3 goes to 6, and 6 goes to 3. So this is a little 2 cycle, or in other words, a transposition. Okay, and so those 2 together represent all of what's going on here in this 2-line notation. Okay, and then if we color code it again, what we'll see is it also leads to an inversion, because if we color code 1, 4, 6, 7 is black, 2, 3, 5, 8 is red, we can see that each time you perform this shuffle, cards values of one color get replaced with values of the opposite color. Black 1 goes to red 5 goes to black 7, and so forth. And then here, red 3 gets sent to black 6, and vice versa. So those just switch places every time you form that shuffle. And once again, we get a very different looking shuffle diagram, don't we? Look at this one. It looks like a pair of lungs or something with this line in between. Okay, so why don't we just quickly kind of point this out. So 1 goes to 5. So we need an arrow that goes from 1 to 5, which we do. Where does 5 go? It goes to 7. So 5 would go up to 7. And then 7 goes to 8. So just keep climbing up. 8 goes to 4. So 8 drops all the way down here at the bottom. And then 4 goes to 2 up here. And then 2 gets sent back to 1. And that closes out that 6 cycle. And then we've already noted that 3 and 6 just get sent back and forth between each other. Okay? And then I have a note down here that this shuffle is, quote, the inverse of one that's coming up. It's number 9. It's also identical to shuffle 13, which is one that's coming up.